Let's go ahead and look at assignment 5, the problems, the first three, problems 1, 2, and 3. So our problems are: write a program that displays the dimensions of a letter-size sheet of paper in millimeters. There are 25.4 millimeters per inch. Use constants and comments in your program. Now the term constant is a misnomer if you have used Java or C++ where you have a keyword to actually force something to be a constant. But that's okay. So we're going to go ahead and launch idle. And so what's our information? It's 8.5 and 11, and they're 25.4 millimeters per inch. All right, so letter size paper. Width is 8.5. Let's go ahead and put a comment that that's in inches. In fact, we could call it width I for inches, or width inches, something like that. Now let's do height inches. It's equal 11. Let's change the comments a little. Width of letter size paper. Height of letter size paper. Now let's go ahead and put our conversion ratio. Conversion is equal to, let's see, 25.4. 25.4 millimeters per inch. So now we can calculate the width in millimeters and the height in millimeters using a conversion. So width in millimeters is equal to width in inches times a conversion. And the height in millimeters is equal to the height in inches times a conversion. Then we can print our results. The paper is width millimeter by height millimeter. All right, let's see if this runs. Source must be saved. We can do that. Let's call it p2.1.py. And it says the paper is 215. Okay, so these are obviously way more precise than we really want. That one looks nice. This one looks a little bit ridiculous. But that's good enough. We might add a few more comments. Let's put our name up in the program. All right. So what's the next one? Write a program that computes and displays the perimeter of a letter size and the length of its diagonal. So the perimeter is just 2 times the height times 2 times the width. And the diagonal of it is calculated using Pythagorean theorem. And you can find all this if you Google up diagonal rectangle and perimeter rectangle. You can find the formulas pretty easy, which is why I did not include them there. So display the perimeter and diagonal of the letter-sized sheet of paper. Now, if we'd been putting this in a different file, we would not already have all these variables declared. So I'm going to declare them again, just because realistically I could be putting these all in their own file. So the width in inches is again 8.5. The height in inches is equal to 11. So how do we calculate the perimeter? It's just all the way around the edge of the sheet of paper. It's the width in inches plus the width in inches plus the height in inches plus the height in inches. Or you could calculate it as 2 times width in inches plus 2 times height in inches. Those are equivalent. Either one would work. Or even two times width in inches plus height in inches. And if you wanted to simplify this to just call it width and height rather than width and height in inches, because that's more complicated to talk, you could do that. You could even just call them W and H. But let's just change them to width and height. Alrighty. Now let's calculate the diagonal. The formula for the diagonal is this. The diagonal is equal to the square root of the width squared plus the height squared. And there's always more than one way to express things. Remember that with exponents, we can use asterisk asterisk to indicate that we are raising something to the power of something else. So let's do this. Diagonal is equal to the square root of the width to the power of 2 plus, well, that's there, width to the power of 2 plus height to the power of 2. Then we can print our results out. Print perimeter of the page is. Now I need to remind myself, were the instructions to print these out in millimeters? No, didn't say so. So we'll just leave them unconverted. We'll leave them in inches. Choose commas. And let's do the same for the diagonal. The diagonal of the page is, we don't really need that space there, comma, diagonal, inches. And we could make this a little bit prettier by adding some white space between the arguments. All right, that's number 2. And we have an error because I was using C-style comments, Java-style comments, rather than Python comments. So let's actually put the correct comment symbol in, and we will have much more success. Nope. All right, I did not import the square root function, did I? So up at the top, I could do import math, but the way to take the square root of a value is to raise it to the power of 1/2. So I'll go ahead and just do that instead. There. That takes the square root of it right there. I'm not sure that that's correct. This is not looking good. So since that raising it to the power of 2 or to the power of 0.5 did not seem to work, I want to take one more stab at that. That really should do the square root of it. Yeah, and that worked. But you can also use the math.square root function. And I do not recall which way the book is leaning towards. To use the math.square root function, you need to import the math library. Now the documentation for Python seems to indicate that you don't need to do that, but it turns out, it seems like we have to. So I'm going to do import math, and then down here, where we have our equation for the diagonal, math.square root, like that. And that's our final answer. This will work just fine. And that looks right, the diagonal being 13 inches. All right, let's see what the third part is. I think I may leave that alone. Write a program that reads a number and displays the cube, square, and fourth power. Use star star only for the fourth power. Well, how do you calculate the square of a number? You just multiply it by itself. So x times x would be the square. X times x times x would be the cube. X times x times x times x would be the fourth, except they asked us to use the star star operator for the fourth power. So that'd be star star 4, indicating it was to the fourth power. All right, I'm only going to do the first part of it, display the square. You can do the cube and the fourth on your own. So assignment P2.3. Let's pretend I can type. And let's get this up at the top of the page. Alrighty. So the program will ask the user for a number, display the cube, well, the square, the cube, and the fourth. Alrighty, so let's go ahead and ask them for the value. X is equal to input, enter a number. Now we could convert this either to a float or an int. Let's just convert it to an int. X is equal to int x. Now let's calculate the square, the cube, and the fourth power. Print x squared is x times x. And then so when you do x cubed, it'll be x times x times x. And when you do x to the power of 4, it'll be x asterisk asterisk 4. Enter a number. Looks like I could use a space here. 10. 10 squared is 100. Okay, that should be enough information to get that done. The next one requires the turtle library. You have to get import turtle to work. Some people had a problem where they had a turtle.py file saved. So we should give this a different name other than turtle.py. I'm going to modify the instructions right here. Enter the following code. Save the program as, I don't know, we cannot call it turtle.py. That is a bad choice. So let's just call it turtle example, followed by your initials. Something like that. Run it and screenshot the result. All right, if we have that, and we have this hint, the diagonal of a rectangle can be calculated as, hopefully that's enough information to go by, especially with the video. So I'll go ahead and upload the modified instructions and the video, And hopefully that'll help everybody who is having problems with this.